Hey, what's going on, guys? We have another problem that we can solve, and this one has to do with voltage and the resistance and the amp. So I'm not gonna go through all this definitions and resistance and all this information that you already need to know about this, but we know that the current has to do with voltage divided by the resistance. So we're just gonna use the information that we have, and we're gonna use the Kirchhoff loop. Kirchhoff loop, it means what goes in must come out, and has to do that whatever goes in is the same thing, same amp, the same current that that goes out. So we're gonna start by looking what we have. We have two loops. The first loop is that we know that to find the current, we're gonna go step by step. So we know that the Kirchhoff's law that says that the 19 volt, the differential, let me go back. The differential voltage goes in has to equal, the equivalence of voltage has to equal to 0. And that means whatever goes in must come out, and we're going to do the 12th, we're going to do the first loop, and that's the 19 volt. Because there is a resistance, they will have a current drop, and that's, let's say that first line over there, we call it E1, and that's times the resistance, ohms, minus, we have another current drop, and that's the E3 of 100 ohms. Okay, and then we're gonna, there's a battery, there's a second battery, and that's another current drop of 12 volt, and all of this has to equal to 0. Okay, and the second loop, so this one is the first loop. The second loop, we have a differential voltage equivalence that will equal, has to equal to 0, and that's 12 volt. We have a current, we have an increasing of currents because the current goes up, and that's plus 100 ohms times the E3, and then we're going to have a current drop again, and that's minus E2, 200 ohms. All of this, so it's supposed to equal 0. So if we go to the, let's do two lines here. Let's do the first loop will equal 19 volt minus 300 E1 minus 100 E3 minus 12 volt, and all of this is supposed to equal 0. Okay, if we simplify, we can do 19 minus 12 volt, and that will give us 7 volt minus 300 E1 minus 100 E3, and this will equal to 0. And if we simplify the negative, we can bring this side here. On this side, we can have 300 E1 plus 100 E3. Okay, this is the first simplified loop that we can have, and we're going to use this one for later. The second loop, it will give us 12 volt plus 100 E3 minus 200 E2, and this is supposed to give us 0. And if we simplify, we can just put this one into the other side, and that will give us minus 100 E3 plus 200 E2. Okay, and then what we can do is to isolate. We know that if we come back on this side, we know that E1, because of the junction separated in two ways, it has to do with the whatever ampere that goes out from the E1 will be E2 plus E3, and we're gonna use this equation to substitute in this one here. So what we can do, it's 7 equal 300 E1, and that's E2 plus E3 plus 100 E3. So, and then we can just multiply the 300 in this inside, and that's 300 E2 plus 300 E3 plus 100 E3. Now what we have is 7 equal 300 E2 and plus 400 E. And then if we isolate either of them, the I2 or I3, we can find that 7 minus 300 I2 divided by 400 will equal I3. Okay? And we can use this I3 to replace in this equation. And this one is 12 equal minus 100 times the E3, and E3 we know it's 7 minus 300 E2 divided by 400 plus 200 E2 multiplied by 7 divided by 400, and that's minus 175 plus 100 times 300 divided by 400, and we equal 75 E2 plus 200 E2. So 12 plus 1.75 equal 75 E2 plus 200 E2. So this one will give us 12 plus 1.75 equal 1375, and 75 plus 200 will equal 275 E2 will equal 0.05 amp. Okay, now we have the I2 at 7 equal 300 I2 plus 400 I3, and we can replace the I2 300 I2 by this one, 0 times 0.05 plus 400 I3, and this will give us the answer for the I3. So 300 times 0.05 equal 15. So 7 equal 15 plus 400 I3, and 7 minus 15 divided by 400 will give us the I3. So the I3 equal 7 minus 15 equal minus 8 divided by 400. And this one, the I3, it's minus 0.02 amp. Okay, and then if we go back to this equation to find the I1, 7 equal 300 I1 plus 100 I3. We can replace the I3 by 0.02. So that's 7 equals 300 I1 plus 100 multiplied by minus 0.02. Okay, so this is 7 equal 300I1 plus 100 multiplied by 0.02 minus 0.02, and this one will give us minus 2. So 7 plus 2, that equal to 9, equal 300 I1 I1, so 9 divided by 300 equal I1. The amp in the first loop is equal 0.03 amp.
So now they are asking us what is the potential difference in the resistance of 100 ohms.
The formula is amp equal voltage divided by resistance. So we can just replace the I3, that's 0.02, is going to be voltage divided by the resistance, that's 100 ohms. So the voltage will equal 0.02 multiplied by 100 ohms, and the voltage will equal 2 volt.